Good morning students. Today we'll see the topic is high-speed networks introduction. First we see the prerequisition of the high-speed networks. It's the basics of computer networks. In computer networks we know the definition of networks, types of network topologies, OIC layer, switching techniques, congestion and traffic control, then quality of service. Next we see the objective. The high-speed networks, the objective is to familiarize high-speed networks to learn different wireless LAN network technologies and its application. The third objective of the course is to learn the concept about ATM, to know techniques involved to support real-time traffic and the congestion control. The last one is to know the quality of service and role of support protocols in high-speed networks. Next, introduction. Here the terms related to high-speed communication networks, including network and end system architecture, definition and high bandwidth and low latency communication. A high-speed network based on distributed queuing dual bus and synchronous optic network, that is the SONET. Asynchronous stands for mode ATM, FTTI. It can satisfy the demand for more bandwidth, integrating the services that are like both real-time and the other communications, and we know the applications of high-speed networks. Next is the data communication. The word data refers to information presented in whatever form is agreed upon by the parties creating and using the data. The data communication or exchange the data between two devices via some form of transmission medium such as wire, cable or wireless medium. Here we consider the 5 components of data communications. One is the sender, receiver, then medium, message and protocol. It's the main components used in the data communication process. Next one, networks. A network is a set of devices. It's sometimes called as a node. The set of devices connected by communication links. A node can be a computer, printer or any other device capable of sending or receiving data generated by another nodes on the network. Next, the history of the networks. The rapid growth of computer networks caused compatibility problems. ISO recognized the problems and released the OIC model in 1984. OIC standards for open system interconnection consist of 7 layers. The use of layers is designed to reduce the complexity and make standardization easier. ISO means International Standard Organization, OIC means Open System Interconnect. Next, models and standards in communications. In communication, the established standards. Standards are known as protocols. In implementation, a framework is helpful in the design for hardware and the software for communication. OIC and ISO models serve this purpose only we are using in the network. Next one is the network is a set of nodes connected via physical link. Here have 3 processes. One is the distributing process, and the sharing and data centralization, security and robustness. The network criteria we consider 3 factors. One is the performance, another is the reliability, security. Performance, the transmission and response time. Here consider the throughput and delay. Security, the privacy and integrity of communication data. Next, data representations. Here we have various types of data is used in the computer network. For example, text, numbers, images, audio and video. Video is a recording or broadcasting of a picture or movies. Audio means recording or broadcasting the sound, the music. Image is composed of matrix of pixels. This type of data are used in the computer networks. Next one is the data flow. Here the data flow have a 3 way. One is the simplex, second one is the half duplex, third one is the full duplex. Here the simplex is a unidirection of data. It's the sender to receiver or receiver to sender. The station, the next one is half duplex. Here the station to station, it's the sender to receiver or receiver to sender, but the time is different. Direction of data at time 1 means the direction of data at time 2. It is the receiver to sender. Then the third one is the full duplex. It is the bidirectional. Here the direction of data all the time. Next, types of connection. point to point and multi-point. The point to point means the session on to the session is connected as single link. The multi-point means here using the more than one point. Here the mainframe is link connected to the various session. Next, categories of topologies. Here we consider 4 main topologies: list topology, star and bus ring topology. Topology is the set of elements. Next, layered approach to communication. We consider the 7 OSI layers. The first layer is the physical layer, the second the data link, third is the network layer, fourth is the transport layer, fifth one is the session layers, sixth one is the presentation layers, seventh one is the application layers. Here we consider the switching techniques. In large networks, there can be multiple paths from sender to receiver. The switching technique will decide the best route for data transmission. Switching techniques used to connect the system for making one-to-one communication. Here the classification of switching techniques. It's got 3 types of switching techniques, but mainly we are using the 2 types of switching techniques. One is the circuit switching, another one is the packet switching, space division switches, time division switches, the datagram approach in the packet switching, then virtual circuit approach. Then virtual circuit approach again 2 classification, another switched. Here the packet switching have a datagram approach and the virtual circuit approach. The virtual circuit approach have again 2 classification, one is the SVC, another one is the PVC. The first we see the circuit switching. Here the circuit switching is a switching technique that establishes a dedicated path between sender and receiver. Circuit switching in a network operates in a similar way as the telephone network. The best example for circuit switching is a public telephone network. It is used for the voice transmission. Fixed data can be transferred at a time in circuit switching technologies. In communication through circuit switching is in 3 phases. The first one, circuit establishment. Second, data transfer. It's the sender to receiver process. The third one is the circuit disconnect, the call disconnection. It is the circuit switching process. Next one is the packet switching. The packet switching is a switching technique in which the message is sent to another place. It is divided into small pieces and they are sent individually. The message split into small packets known as packet, or packets are given a unique number to identify their order at the receiving end. Here we assign some address for the source address and destination address and sequence number. Every packet contains some information in the headers. The packet will travel across the network taking the shortest path as possible. So all the packets are reassembled at the receiving end in correct order. If any packet is missing or corrupted, then the message will be sent to the resend the message. And finally, if the corrected order of the packets is reached, then the acknowledgement message will be sent receiver to sender. Next, see the diagram representation for packet switching and the circuit switching. The first one is the packet switching. Here the data is divided into small packets. It is sent to the different paths. Here S1, S2, S3, S4, S5, S6, 6 sessions nodes are connected here. The A is the sender, B is the receiver. The data is sent to different paths, but at the end of the process, the receiver will the order 2, 4, 3, 1. He will reorder based on the sequence number. Next, second one is the circuit switching. Here also using the 6 node. The sender A send the message S1 to S2, S2 to S4, S4 to S6, and finally receive the message at receiver P. It is the process of switching techniques in the packet switching and the circuit switching techniques. Thank you.